Today I'm going to show you how to package a pre-compiled Go binary using fpm and fpm-cookery to make a system package you can deploy to your system, such as a RPM or a deb package. So to start with, I have a directory on GitHub full of all my existing recipes. So we'll clone that down. These are all open source, you can have a look around them, see different ways of approaching them if you need to. So we copy the repository, we clone the repository, join in, then let's see what version of Ruby it thinks we have at the moment. So RBM local. So we currently have no explicit versions of Ruby configured for this repository. I'd like to try and work on vaguely modern versions of Ruby to avoid bugs that have already been fixed by other people. So we're going to work today on 2.6.0. And we can test that that has worked by running ruby-v. Okay, now we have that, we're going to run bundle install, and that will bring down all of the gems that we can use for this project. So bundle install. But to be honest, the gems we mostly use is fpm-cookery. So fpm is a program by Jordan Sissel that wraps package management systems to help you build packages without needing to know every one of the intricate details. It doesn't make packages of quite the same standard as one that's been hand done by an expert maintainer, but most of us aren't expert maintainers, so this actually gives you a much quicker and easier way of getting it running. fpm-cookery uses fpm underneath, but provides a nice Ruby DSL to let you define how the packages should be selected and built to make it a little bit more reusable without everything being specified on the command line. So now we have the gems installed. I'm going to create a new directory for the thing we're going to package today, which is docker push rm. So we're going to get docker push rm, and we're going to work in this directory. So fpm-cookery, as the metaphor would make you expect, uses recipe files. And a recipe file is a tiny chunk of Ruby code that is very boilerplate, as you can see by this template. But once you've specified this is enough to build a package. So we're building docker push rm. The description for this I've actually got typed out already to avoid you having to watch me type incoherently for a couple of minutes. So the package description is update your container repo readme on Docker Hub, Quay or Harbor for a single Docker command. So what most people don't know is when you push a new image to something like Docker Hub, it doesn't actually update the readme. You actually have to do that manually as a separate step, and it's very easy to lose track of that and have very old out-of-date documentation. The home page for this project is this URL on GitHub. The maintainer is set to my email address because I'm the maintainer for this code. It doesn't make a claim on the ownership of the package itself, that's owned by the person who wrote it, so Christian Kornick. But I am the maintainer of this bit of code, and he shouldn't be bothered if I make mistakes in this. So in terms of the name of the package, we're going to want the package to be called docker push rm. The version they currently have, which I looked up on the web earlier, is 1.4.2, and it is actually published under the MIT license. So source is the next one of the longer values. This is going to be where we pull the binary package down from GitHub, and you can often find this on the release pages. So this URL here is the URL of the latest version published to the GitHub releases, and what we're going to do is use a little bit of Ruby to turn it into a vaguely more less linked package. So by having the versions separately, we only have to change the version number to make it work rather than editing the string. The SHA is the binary that we're going to compare, the hash of the binary that we're going to compare against to make sure that it's not been edited underneath us. This guarantees that if someone's made a change, the build should fail. Because we've never used this before, and we're essentially trusting someone else's third-party binary, we're going to take the SHA that gets returned to us. So the build step, we won't need to do anything in because this is a Go binary that's already been built. And the install step, we're just going to specify that we want to install the binary to... so we're going to specify build and that's going to be the directory that the package gets pulled down to our local system and put into. In this case it should hopefully be called docker push rm, but we'll check that when we run the first build. So the install step will use the source location here, it will pull that file down, put it into a directory called tmb-build, expand it out in there. We're then going to tell, you're going to use this function here, build here, which knows the layout of that path, and it's hopefully going to find a file called docker push rm, and then it's going to install that into our system bin directory, which in this case should be user bin. So now we've got that, let's come out there, and then we're going to run the rake file to actually try and build this. So to do that, we do bundle, actually let's just do fpm-cookery. And we're going to build this for, let's do it on this machine itself, which is going to be an RPM because it's a Fedora based machine. So fpm-cook, target will be RPM, and we want it to package. So this goes away, you can see it fetching the package down, and it has failed on the checksum because the checksum we gave it is not a valid one. The actual checksum on the binary is this. If you were building something for production use, you'd actually go and double check the published checksums on the release page. Because I'm doing this for just a test, that's not such a big problem, so I'm going to take what we've been given and hope that no one's playing anything strange while we're doing this. So now, we've updated the shard, we'll run again, and this time we get the complaint that the docker push rm does not exist in the build directory, so we have guessed the name wrong. So from in here, we'll do temp build, and we can see where the packages have been expanded, and it's expanded it into a directory called docker push rm amd64, and the name of the file in there is actually this one. So we were guessing that it was just docker push rm, but it's actually docker push rm Linux architecture specifier in a subdirectory. So let's grab that part of the path out and then re-edit our recipe. And then the build for this is just changing the name on it. Yes. So we're telling it to get that name there. Am I missing anything, or should this be okay? No, I'm missing the second option. So we're telling it this is the file to take, but we don't want to create the file in the package like that. We actually want the file on our machine to be called pushrm. So we'll use the build command to find where the file is locally. It will then return that value to bin install, and bin install will then copy the value returned from this into this. So the file on that in the package on that system should look like docker pushrm. So let's run that and see if we actually get a clean build, which that's better. So now we've got a build that actually has run. Let's check that the package is correct, which is fpm-cookery. So query information, long format, look at a package, not a package that's installed, and then we can use the package that we've just built here, which should always be relative to the directory you're working in. So package docker pushrm, and there we can see that we have the package we just built, docker pushrm. It's got the version number, it's got our architecture, and it contains a little bit of metadata that we put in the top of our template. So we can see that our package itself contains a single command, and it's actually worth checking, is that an executable command? So when we install it, will it run? And the answer is it's not an executable. Okay, so we'll go back to our recipe file, and in the recipe file we'll make that file executable, so when it gets deployed to the system we can run it without manually setting permissions. And we do that with the chmod function. We will make that executable by everyone, so chmod 755, and then we use the path we have before, and we then rerun the fpm-cook and then recheck the package with its permissions. We now have an executable file, which is what we're after. So now we have this, we can actually try and do an install. So if we do sudo dnf, which is Fedora's more modern package manager, install and go pkg docker, and tab complete's taking a couple of seconds, and run that. Keep my fingers crossed I don't type this into a box you can see. Okay, if we upgrade to Fedora 32 has made Docker unhappy, but here you can see that it will install the docker pushrm package, and if we install that package and then look at user bin docker pushrm, we can see the package is installed with the correct permissions and is executable. And that's all you need to do to build a package if you're working from a pre-compiled source. So to finish this up, we'll create a new branch, which is docker pushrm. We'll double check the file that we've created, and do not add the entire directory, because in this directory you'll have all the temporary builds you've created, such as the cache, the package, temp build and the temp dest. And this can actually be surprisingly large. So for a tiny bit of Ruby code, we're actually carrying another 16 odd meg, which is not what we want. So we'll do git add recipe, recipe, git commit to the branch, add the push iron recipe file, and then we're pretty much done. The last thing I'll show you, which I don't use as often as I should, is there is a command called hub that lets you interact with Docker with GitHub from the command line. And if you do docker hub pull request no -edit, that will then raise a pull request from the branch you're on with the commit message as the pull request message. Once you've pushed the branch. So if we just push that, and then rerun the pull request, and then voila, there's a pull request created on my repository. Hopefully this is helpful. Thank you for listening.